All right, this is a little help video for ETA 7.2. In the figure, the center of gravity of the pole held by the pole vaulter this again is my numbers, is 1.8 meters from the left hand. His left hand, see how it says FL, and the center of gravity they just told me, the location is his left hand is 1.8 meters. Okay, and the hands are 0.725 meters apart. So now I know this distance, and that is 0.725. The mass of the pole is 5 kilograms. So now I know the mass of the pole, which I will need to know the weight of the pole. And in ETA, we have to use 9.8 for little g. Now, what do they want to know? Calculate the magnitude of the force in newtons exerted by his right hand. So let's take a look. I know the mass of the pole. I don't know anything about his left hand. I don't know anything about his right hand. So, for example, I can sum the forces in the y direction. It will be equal to 0 because this is an equilibrium. I have upwards force from the left. I have downwards force from the right and the weight of the pole per their nomenclature. That is equal to 0. There are two unknowns in that equation, unfortunately. So that equation by itself will not allow us to solve for the answer. Now, there are no forces in the x, so that's the only reason why I'm not doing a summing. Okay, I can write it, summing the x. There is no forces in the x. They add up to 0. So the next thing I'm going to do is I'm going to solve or write my equation for torques. This is an equilibrium, so um, I have 3 equations I can write. So let me ask you this. Why I could take the center of gravity of the pole as my axis of rotation, except that would be a bad choice because I now have a torque caused by force in the left, force of the right, and that would mean 2 additional unknowns. I do know all the R values, but if I were to pick, for example, what do they want to know? The first question is the force from his right hand. I don't know his force of his left hand. So if I picked his force of his left hand, the only 2 forces that cause torque now are the weight of the pole and the force from the right hand, and therefore I have eliminated an unknown. So I'm going to use that one. This causes a negative torque. This causes a positive torque. I'll call that torque R, torque W. And so I know that torque from his right hand subtracted by the torque on his from the weight of the pole about that axis of rotation that we picked is equal to 0. Now I'll expand the torque equations. So I have force from the right hand times the distance from that axis of rotation. Oh, look at that. We know that. Times sine of 90 degrees. So that's 1, minus the torque caused by the weight, we know that, mass of the pole, which they gave us somewhere in here, yep, 5 kilograms, times little g, times that distance, which in mine is 1.8 meters, is equal to 0. And now I have the ability to solve for the only unknown in that equation, which is the force from his right hand. Now they ask to calculate the force from his left hand. Well, now that I know the right hand and I know the weight of the pole, I can now use the sum of the forces in the y direction to find the force from his left hand. Okay, there's some help for that. Next, this one's a little bit trickier. Again, it has to do with being able to label, and think about what distances there are. Okay, you've been hired to design a family-friendly seesaw. Your design will feature a uniform board of mass, 5 kilograms in my case, of length 9 meters. Uniform, what does that mean? That means the mass of the board is uniform across all of it, so the center of gravity of the board will be smack dab in the middle. So if the length of the board is 9 meters, the center of gravity of that board will be at 4.5 meters, okay? Again, back to the thing. Feature of uniform board that can be moved so that the pivot is some distance d from the center of the board. So notice this picture. The fulcrum is located to the left by some distance d of the center of gravity of the board, or the center of mass. So however you would like to think of them, they are the same as long as we are in a field of constant little g, which we are. This will allow riders to achieve a static equilibrium even if they are of different masses, as most people are. You have decided that each rider will be positioned so that his center of mass will be at an offset of 18 centimeters from the end of the board when seated as shown. So here is the offset. So we have lots of information here. They told me that this is 0.18 meters. That's 18 centimeters. So this is 0.18 meters. Again, what was the total length of this board? It was 9 meters. So I'm going to go up here and I'm going to draw that. This right here for me is 9 meters. Um, I know that from here, which is the center, over is 4.5 meters. But where is the center of mass to this person? Well, I've got to subtract that 0.18 meters. So that is 4.5, that's half of the board, minus the offset, which is 0.18. So I find that to be on mine to be 4.32 meters. Same thing for this location, because that person's offset is identical to the first person's offset. So 4.5 minus 0.18 gives me 4.32 meters. I don't know which ones I need yet, but I'm going to label everything that I know. Okay. All right. Now what am I going to do? I have given the child's mass. I have been given the adult's mass, which is 5 times that of the child. Determine the distance d in meters. They're asking for a distance, going to have a torque. Can't solve of that problem without a torque equation because there's a distance associated with it. So I'm just drawing where the man is. So this is the weight of is this what do they call that? Parent? Adult. They called it weight of the adult. Force of gravity adult, just less symbols. This is the weight of the child. The dot here, we know these distances. Those are 4.32. This is 4.32. And this fulcrum is located to the left of that center of gravity by some distance d. And that'll be important here in just a minute. This plank is not of negligible mass. They told us it has a mass of 5 kilograms. And so that is the weight of the seesaw. Okay, that's equal to the mass of the seesaw times little g. And the only other force that we have is force normal upwards, which is shown at the fulcrum. So that is force normal. Don't know where that is. So we want to know D, and I am going to pick this as my center of, or my axis of rotation. It gets rid of force normal. I know all the other forces, okay? So let's go torque A. That's going to cause it to go in a positive direction. Torque sub S is negative. Torque sub C is negative because it's going to make it turn in a clockwise direction, and that's going to go counterclockwise. So I have all the positive torques, torque from the adult minus torque from the seesaw's center of mass minus torque from the child. All of those added up is equal to 0. Torque from the adult, which is the weight from the adult, times the distance away from the axis of rotation that I have selected. Now look what that is. I don't know. It's not 4.32. It's 4.32 minus D. 4.32 minus D, minus the torque caused from the seesaw, which is the weight of the seesaw, times the distance away from the axis of rotation. By the way, the angles are all at 90 degrees, so that's why I'm not talking about sine 90. Minus let's see, the weight of the child times the distance away from the axis of rotation, which is, let me think, it is not, in this case, it would be 4.32 plus d, okay? So all of that equals 0. Now I can solve it for the only thing I don't know, which is d. So kind of an algebra heavy problem, but take your time. Determine the magnitude of the force exerted on the pivot point by the seesaw. This force normal right here is the force from the pivot on the seesaw. They're asking for the one that the seesaw is putting on the pivot. Well, they're equal in magnitude, opposite direction. So you would solve force for normal using the sum of the forces in the y direction. So I can do that real quick. Sum of the forces in the y is equal to force normal up minus weight of the adult minus weight of the seesaw minus weight of the child is equal to 0. And you can then solve for force normal because we know everything there. So I hope that helps you, and good luck.